Hi, I'm Samira, and this is my personal project. The purpose of my personal project was to innovate my skills in robotic technology. The goal of my personal project is to develop my robotic technology skills and to apply my skills to a robotic arm. Within my project, I applied both knowledge I had prior to the project and new knowledge. In terms of prior knowledge, I have some experience in Arduino coding along with soldering, but there were many factors that went into my new knowledge that I have learned. Here I'm writing notes of the information I learned regarding coding and how to use the MIT App Inventor.
Moving on to planning, I created a table in order to determine the total cost of the project. I have 3 columns, the first being category, the second being items, and the third being cost. First category I have is software. The software that I used is SolidWorks Standard. It should be mentioned that I did not technically buy this, but already had this resource available for my sister. I put it in the table because I thought it was necessary because of the staple in the process. Moving on to the second category of circuit-related items, or items that went to the motherboard or servos or anything of that type of sort. I have all the items listed in here, and then I have the price on the side. Scrolling down, I also have the other items, and this is just the wood, the drill bits, the wood screws, and the drill itself, and then the cost on the side, and then I have the total I spent right here, but then I also have the total worth cost on the right here as well.
Moving on to the actual process of building the robot, I used the table before to buy items regarding my project as it made things a lot simpler and was a lot more organized. Most items did not arrive until months after ordering due to COVID-19. This definitely took a toll onto my overall plan for the project as it set back many goals for mine. To continue, as the items started coming in, so did the printer. I started printing immediately in order to save time. I was able to design prints using the SolidWorks software and measure them based off the dimensions of the circuit board. Here are some time lapses I've captured of the 3D printer. Additionally, I also had to build a motherboard, or the PCB. I started with soldering the small components first, the resistors and the capacitors. Then I inserted the soldered male pin headers to the PCB, which will also be used for connecting it to the Arduino board. Next, I placed all female pin headers in place and soldered them as well. As for stepping motors, connections, and pins for selecting the stepping resolution, I use male pin headers. This way I can directly connect to the motors to the PCB and use jumpers for selecting the stepping resolution. Then I soldered the terminal blocks and the trimmer and the voltage regulator, which now I have completed the PCB. Now that the PCB is done, I can insert the drivers and connect the motors to it. First, I placed the jumpers for selecting the stepping resolution. I selected the 16 stepping resolution by connecting the MS3 pins of the drivers to the 5V. Then on top, I placed the DRV8825 drivers as well as connected the NRF24L01 module and the HC05 Bluetooth module. Now I can add the PCB to the Arduino Mega board. What's next left to do is to create the app for the actual controlling part of the robot, and I'm using the MIT App Inventor. Previously, I have took notes when I was investigating more into my robot, so I have some experience now regarding the MIT App Inventor. So in order to define the Bluetooth module and initialize its communication in the setup section, I need to look at the incoming data from the smartphone and according to it, tell the robot on which direction to move. And if I look at the Android app, it can simply sense numbers from 0 to 15 through the Bluetooth where the buttons are pressed. After that, then I press save and run the app with the current positions of the stepper motors in arrays, and then I press the run button and see which way it executes. This app can be in different types of forms, in phone, tablet, and monitor, so it's universal and really easy to access. To conclude, this is my end product of my personal project. As you can see, the robot has the ability to move and pick objects up. It is far from perfect, but it definitely achieves my goal. I have gained a lot of new knowledge that is useful towards my personal technical innovation. I'm grateful for this opportunity to learn more about robotic technology. Thank you so much for watching.